week, Friday, when we met, we talked about the law of sines. And then on Tuesday, we talked about the ambiguous case of the law of sines. When if you're given your angle side to side, that you got to check for if it's 0, 1, or 2 triangles. Then Wednesday, we did a little practice with law of sines and some solving. Yesterday, we did law of cosines discovery. Now, we were able to kind of gloss over these because you did law of sines and law of cosines in your geometry class. So this was more just a refresher for you. Today, our focus is going to be LOS versus LOC. Okay? It's a battle royale cage match to the death. Okay? 2 laws enter. You can only, I should say that you can't only use one because in law of cosines they use both. You got to figure out which one you're going to use first. Okay? So it's first man, last man standing match or something like that. I don't know, I'm making stuff up here. Okay? But so we got to know. So we came up with this little like cheat sheet, if you will. Okay? So when do I use law of sines versus when do I use law of cosines? Okay? Well, law of sines, remember, let me see if I can, if this all comes, look at that, this is all coming back to me now. Okay, so law of sines is sine of A over side A equals sine of B over side B equals sine of C over side C. Okay? If you have one complete fraction, okay? So if you have one complete fraction in the law of sines, you're going to use the law of sines. So if you have an angle and its opposite side, automatic, use the law of sines, hammer it up. Okay? The one kicker, and it's a cautionary tale, okay? The cautionary tale is the law, or finding the inverse sine, if you will, only finds an acute angle. So you have to use the law of sines to find the smallest angle first. Again, I remind you, or I ask the question, how do I know in a triangle which angle is bigger or smaller? So smaller angles have shorter opposite sides. Bigger angles have bigger opposite sides. Yep. So if I'm looking at 2 sides and I don't know those 2 angles, because I will only be given 1 angle in this scenario. So if I'm given 2 angles, I know all 3 angles. So if I'm given 1 angle and I got to find that other one, I got to look at the smaller of the 2 sides. Okay? All right? Love it. Law of cosines. You only have to use the law of cosines if you're in a side case or a side angle side case. That's the only time that you have to use the law of cosines. And you should only have to use the law of cosines once. Because when you apply the law of cosines, that gives you that opposite side, or that gets you an angle that then opens up the law of sines. Okay? Now, cosines will get you obtuse angles. So cosines, you find the biggest angle first. Okay? Now, I don't have the law of cosines memorized, which, by the way, is a bold-faced lie, because I've been doing this so long. I haven't memorized. but in my brain, I don't immediately go to that. I've memorized the pattern. Okay? So the pattern is this. If I have one side, I'm going to square it. Then that's going to be equal to the sum of the squares of the other two sides, Pythagorean theorem, minus twice those same two sides times the cosine of the angle that I was taking the side of. Okay? AB, AB, C. Okay? Or if we needed to switch that around for some reason, which, sometimes you'd have to, so then it would be B squared. These two would be A squared and C squared. These two would be A and C. This would be, memorize the pattern, not necessarily the actual. All right? And there it is. There's all three. Okay? Which you have on your packet. Okay? So here is the example that I want to do. Because it combines everything that we need. Okay? So we've got L, R, and H. Triangle LRH. Okay? You know why we chose L, R, and H?
It's rock.
Yeah, bingo. With rock hill. Okay? Right? Plus, it's not A, B, and C. Okay? So, again, me. How I do things. Not necessarily the way you have. But if it were me, I would draw myself any old triangle. Does it have to be accurate? No. Okay. Just gotta be a triangle. Okay. And then put stuff in there. So if I put 40 here, that means that is angle L. If I put 24 here, that means that this is angle R. And if I put 50 here, or anywhere, that means that that's angle H. Does it matter where they go? H to the no. Now, this is a side case, right? We don't have any angles. So that's automatically law of cosine. Which angle, L, R, or H, should I find first? R? Do we agree, print in R? You think H, okay? Why do you think R? Because it's the smallest, okay? Why do you think H? Because it's the biggest. Which both of you are correct in that R is the smallest, H is the biggest, okay? What did our cheat sheet just tell us to do? Law of cosine, we find the largest angle first, okay? So we're going to go H. If we had an angle, we would go with R because law of sine we find the small. Law of cosine we find the biggest one. Because again, that cosine, remember when we were doing inverse cosine? Well, inverse sine, right side only. That only gets us inverse cosine at the top. All right? So we're going to find H first. So that's going to be 50 squared equals 24 squared plus 40 squared. Does it matter what order those two are in? Nope, it doesn't. Okay. Minus 2 times 24 times 40 times the cosine of H. Probs, going to need ourselves a calculator. So on page 2 of the packet yesterday, there was a spot where you solve for the cosine of each angle, which is fine, great and handy, but that's just more stuff that you got to remember. Me, I like algebra. And so I'm just going to do all of this algebra right here. So 50 squared is 2,500. 24 squared is, wait, no. Yeah, 24 squared is 576. 40 squared is 1,600. 2 times 24 times 40 is 1,920. $2,500 minus 576, not 500, minus 1,600 is 324. Right? So then now what do I have to take? Inverse cosine of that. Inverse cosine negative 324 divided by 1920 gives me, I get 99.715 degrees. Yes? Now, for me, I'm going to leave that on my calculator, and I'm going to put my calculator off to the side with that still on there. Okay. So now we have angle H. Angle H here was 99.715 degrees. So I have that complete pairing of, for law of sines. I got an angle and its opposite side. Out of curiosity, 99 degrees is acute or obtuse? Or right? Obtuse, right? Can I have two obtuse angles in a triangle? No. So does it matter which angle I find next? No, it does not. Now, if that were an acute angle, I would definitely need to find the smallest angle next. Okay? With me? Okay.
Wait, why does that matter? You can have one anyway.
Right. But if we found it for some reason, it didn't, just find the small. Then you're in that mode of always finding the smallest. Okay? Okay? So which one do you want to find next? R? Let's go R. Okay? R. So we would say here then that the sine of 99.715 over 24 is equal, over 50. I was getting ahead of myself. Over 50 is the sine of R over 24. Which means that 24 times the sine of 99.715 all over 50 is sine of R. Which means that R is the inverse sine of that. Now, does anybody know why I set my calculator off to the side and left it there? Because now it's exact. I'm not rounding it. instead of typing in 99.715, I've got it on my calculator. So I'm going to take the sine of that answer, sine, open parentheses, answer, equals, then multiply that by 24, then divide that by 50. This 50 is bugging me, sorry, it's a bad city. And I get 0.4731. Then I'm going to take the inverse sine of that answer, and I get here that angle R is 28.237 degrees.
Do you have a certain place you want to swim to?
We'll tell you. Yeah. So for right now, like when you're doing these problems, if you don't have that answer key in your calculator, as many as you can.
Okay.
The more is better. Like or I shouldn't say yesterday. Wednesday, when we were working around in the rooms and chairs and stuff, people were getting off by significant amounts because they were rounding shorter than us. Okay. On all of the answer keys that I produce, I do exact. Like I do ANS, the answer stuff on my calculator.
Okay.
And we'll give some leeway there. But like on Wednesday, some people were like off by 0.5. That's way outside our range.
Right.
Usually we're like a 0.2 maximum leeway. So like 28, we would have, if you gave us somewhere between 28.0 and 28.4, we would be okay. Okay? Otherwise you're rounding too much too early. So then we do 180 minus 28.237 minus 99.715, and we get angle L, this is now, is 52.048 degrees. I believe on Thursday the 16th, which is the day we're taking the test, I believe I have everything rounded to 2 decimals. It's either 2 or 1. I don't remember. Questions on that? No, you got it. Yep. So you have 2 things to get done now going forward. Okay? Remember that Tuesday we don't have a class that meets because it's ACT day. Okay? So it's a independent learning day because we're not hosting class meets and that kind of a thing throughout the day. So what you have to do between now and Wednesday's class, okay? So between now and Wednesday's class, you have the law of cosines packet from yesterday that you can complete. Please complete. And I have this wonderful worksheet for you to complete also. It's 10 questions on, this kind of stuff that we were just doing. Law of cosines versus law of sines. Okay? Sounds great.